Number 6, use Stokes' theorem to calculate the flux of the curl of f for this vector field f here through the cone. Z is equal to 1 minus the square root of x squared plus y squared. Z is greater than or equal to 0. So this is a cone here. Okay, we know by Stokes' theorem, the integral, we call this surface S here, of the integral, the flux of the curl of f dot n d sigma is equal to the integral along the boundary, along the edge of the boundary of our cone here of f dot dr. So what do we end up with? What do we end up with here? Okay, we don't want to compute this. The thing I do not want you to do is, oh, you need to compute the curl of it. That would be very, very messy to do. And then do this double integral. It's far, far easier to just integrate f along the boundary here. Okay, so what do we have here? Okay, how do we parameterize the boundary? This is just going to be circle of radius 1 in the xy plane. Cosine t, sine t, 0. T runs from 0 to 2 pi. R prime of t is negative sine t, cosine t, and 0. F of r of t. So take r of t, substitute it up here, and you end up with, let's see here, x is cosine t, y is sine t, times e to the 0, comma, x is cosine t, e to the negative 0 minus 0 e to the sine t, comma, sine of x is cosine t, y is sine t, z is 0. So this simplifies down a lot here. Cosine t, sine t, e to the 0 is 1. Cosine t times 1 minus 0 times who cares, and then sine of 0 is 0. So that simplifies down a lot here. So then f of r of t, dot product r prime of t, this dot product this is going to be negative cosine t sine squared t plus cosine squared t. So then the integral we need to evaluate is the integral from 0 to 2 pi of the expression that we just wrote down here, negative cosine t sine squared t plus cosine squared t dt. Okay, so then this is what we have to do here to evaluate this integral. Splitting up into two parts, integral from 0 to 2 pi of cosine squared t dt will just be pi, plus the integral, I guess, minus the integral 0 to 2 pi cosine t sine squared t dt. Easiest way to do this substitution, u is equal to sine t, du is equal to cosine t dt. And so when you do this, you end up with integral of u squared du, but then the bounds are from 0 to 0, and this integral just ends up as 0. So our final answer here is just pi. So this is far, 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 far easier than doing curl calculations on this.